with these solutions. So with these different numbers that we were able to come up with, 6, 1, 7, 2, whatever other options you thought of, 1, 0, there's multiple solutions. There's multiple routes we can go about. There's not just one answer. There's not just two answers. There's, you could probably say, an infinite number of possibilities or solutions. And so we're going to talk about how we can represent this infinite number of solutions, how we can represent this whole range of solutions with these inequalities. So I'm going to show you a picture. So I have 3 graphs on here. I want you to come up with some things that you notice about these graphs. What is similar about them? How are they different?
The line is the same. Boom.
Okay, so if we look at all 3 lines, they're all the same. Okay, so that's something that's similar.
The one in the middle has a dotted line.
The one in the middle is a dotted line? Okay. Good. What else do you notice? All right, so the 2 on the left and the right have, or the 2 on the far right have shaded insides on them.
The line is always in the same spot.
So the line's always the same. Good.
But one of them is dotted.
One's a dotted line and broken line. Yeah, that's what Wyatt noticed as well.
What kind of thing? I don't know. Because that whole puzzle. I think how it has the yellow.
All right, wait. Say that one more time.
Then the fourth one has the yellow.
So this one's equals, this one's greater than equals, and they both have solid lines, while the one that's just an inequality has a dotted line. All right, so today we're going to learn how to graph linear inequalities. So we're going to be graphing inequalities like these, and we're going to learn how to graph the line and how to determine where we need to shade on these lines and how we can represent that solution. So with graphing inequalities, just like other inequalities in the past, we have 4 symbols. We have less than, we have greater than, we have less than or equal to, or greater than or equal to. So these symbols are going to change how we affect our line. If we notice on the example in the past, on the example on that last slide, we had an example where we had a solid line, and we had an example where we had a dotted line. So Wyatt, which one did you notice had the solid line, and which one had the dotted line? What was the inequality? So, when graphing these, if the inequality is an important piece, if the inequality is less than or greater than, it doesn't have that equals underneath it, it's going to be a dashed line. If the inequality is greater than or equal to or less than or equal to, we're going to need to make sure it's a solid line. These will also help us determine where the shading is, whether we're shading the top side of the line or whether we're shading the other side of the line. You're only going to shade one side. You'll never shade both sides of the line. It's either going to be above the line or below the line. We're either going to be greater than the line or we're either going to be less than the line. Yes.
Same thing. Cool. Dang it. I got a notch.
No.
All right. So, in order to graph these lines, in order to graph these inequalities, we're going to need to shade in regions on these inequalities. Those shaded in regions, that is the solution. That represents all of the points on that graph that make that inequality true. Just as we saw in that first warm-up, there are multiple answers you can put in for that first inequality that made y less than x plus 1 true. We found 7, 2, we found 0, 3. We got a bunch of different answers. And so we need to first determine how to check whether a point is a solution to an inequality before we need to learn how to graph. So we want to determine, is the ordered pair negative 2, 1, is this a solution to the inequality 3x plus y is less than negative 4? So we need to determine whether this point makes that inequality true or whether it makes it false. And now we'll determine whether it's a solution or not. So we have 3x plus y is less than or equal to, or less than, sorry, not equal to, negative 4. We need to see if 2, or negative 2, 1 is correct and makes this true. So we're just going to take your x and your y from that coordinate, and we're going to plug it right into that formula. So that gives me 3 times negative 2 plus, sorry, that's going to be a y, it looks like a 4. Plus 1 is less than negative 4. So simplifying this, what's 3 times negative 2? Negative 6. So we have negative 6 plus 1 less than negative 4. What's negative 6 plus 1?
Negative 5.
Negative 5. Is negative 5 less than negative 4? Yes. So negative 5 is farther to the left on the negative direction, so it is a smaller number. So that is true. So because negative 2, 1 made the solution correct, we could say that this is a solution. So yes, negative 2, 1 is a solution to the inequality. So once again, that shaded region on these graphs, that shaded region represents all of the solutions of these inequalities. So we can use this method of checking a solution to be able to determine whether our shaded region is correct or whether it's false. It's a skill or it's something we're going to keep continuing to use. But first, before we do that, we're going to need to learn, or we're going to need to practice graphing these and practice how to start them. So, when we graph, we have a couple steps we can go through. So step number 1, we need to determine, is our line going to be broken, is it going to be a dashed line, or is it going to be solid? So that's going to be step number 1. Step number 2, we're going to graph our line. Step number 3, we are going to check a point. And that's going to help us determine whether where we need to shade on our graph. So these are the 4 steps we are going to use for graphing these inequalities. So step number 1, we need to determine whether it's going to be a solid line or a dashed line. So we saw earlier that depending on whether it's greater than or equal to, or just greater than or less than, determine whether it was a solid or dashed. So looking at this first example, are we going to have a solid line or a dashed line?
Solid.
Solid, because it's greater than or less than or equal to, because we have that line underneath, we know it's going to be a solid line. So next step, now that we know it's going to be a solid line, we need to graph it. So we can graph these lines just like we would any other line, just like we've done in the past. So this is in slope-intercept form. So I know my y-intercept. I know that's negative 4, so I can go down to negative 4. 1, 2, 3, 4. And I can plot my y-intercept. My slope is 1 over 3. So I know I'm going to go rise of 1, run of 3. So up 1 over 3. And because I determined already that it was going to be a solid line, I can draw my solid line through those points. And that's graph. I have my line graphed. So we can graph those just like we've graphed lines in the past, just like we've used with slope-intercept, with standard form. We practiced those before. So we're using that same step, just pretend it's an equal sign if you need to. All right, now we need to check a point. So we need to check a point on one side of this line. If we check a point and that solution and that point is true, which makes the inequality correct, like we saw in that last problem, if it makes the solution true, then we'll shade the side that includes that point. If the solution is false, if the inequality is not true, we shade the other side. So it doesn't matter which side you choose your point from. Personally, I like to go with easy points. Smaller numbers are typically easier. The easiest point, in my opinion, is just going to be 0, 0. So I'm going to plug 0, 0 in for my x and my y in this inequality, and I'm going to see if that makes my inequality true or if it makes my inequality false. So I'm going to plug 0 in for my y and 0 in for my x. So simplifying this, what's 1/3 times 0? 0. Anything times 0 is still 0. What's 0 minus 4? 4. So is 0 less than negative 4? No, that's not true. So because that's incorrect, I know that this is not a solution. So I need to shade the part of my line that doesn't include this. So I need to shade the opposite side. And that is my inequality. So once again, we'll just go through these 4 steps. Figure out if this is going to be a solid or a dashed line. Graph the line. Check your point. And then shade. So see if you can try that same exact example. See if you can try the same thing for the next one. And then we'll reconvene and talk about the third one. So see if you can do this next one, just like we did the first. Alright, so looking at this inequality, did we determine whether it was a solid or a dashed line? Dashed line. What was our y-intercept for the point? 2. So we saw our y-intercept was 2. And what was our slope? So our slope was negative 1. So that means every time we went over 1, we went down 1. Over 1, down 1. So we said it was a dashed line. So we can draw our little dashes on there. Now we need to determine, are we going to shade above this line or are we going to shade below this line? So we need to check a point. Once again, 0, 0 is the easiest point to check. As long as your line doesn't pass through that origin, as long as it doesn't pass through the point, it's a great point to check. So 0 is less than 0 plus 2. 0 plus 2, or sorry, 0 is greater than 0 plus 2 is 2. Is this correct? Is that true? Is 0 greater than 2? No. So because that is incorrect, I need to shade the point that doesn't include 0, 0. So I'm going to shade the top. Yes. So that's because our slope is negative 1, and so we need to go every time we go So with graphing these inequalities, we just need to remember how to graph our slope-intercept form, and then we can go through these points. So remember, slope-intercept form, always look for the intercept first, and then use your slope to continue from that point. But slope-intercept form isn't the only type of line we talked about. We talked about point-slope form, and we talked about standard form. So if you look at your next 2 problems, these 2 problems are in standard form. So we need to think again, how do we graph standard form? So with our standard form, we need to think through those intercepts. So what is my x-intercept? What is my y-intercept? First thing though, is this going to be a solid line or a dashed line? Solid line. Alright, so we're going to need to graph standard form. Thinking back to standard form, we had that cover-up method. This is what we did over before Thanksgiving. So if I want to look for my x-intercept, I need to cover up my y So I have 2x equals negative 12. It doesn't. Don't worry about the inequality necessarily at this point when looking for the intercept. Just worry about. You can just put it as equals. So in order to find that intercept, I need to divide. I need to solve for my x, and we got x equals negative 6. So I can put a point at negative 6. Need to do the same thing for my y. Cover my x, I get negative 3y equals negative 12. In order to solve for this, I need to divide by negative 3. And I get y equals 4. So I can put a point at 4. So I have my 2 points. I know it's a solid line. So I can graph my line between this. Once again, I can see that this is a rise of 4 and a run of 6. So I know I'm going up 2 over 3, up 2 over 3. Are you okay?
No.
I promise you can't do it.
So this is standard graphing standard form. This is what we did right before Thanksgiving, where we did that cover, where we covered up one of the letters and then divided to find that intercept. Cover it up, divide to find the intercept. All right, so we have our line graphed. We know it's a solid line. We need to once again check a point. Figure out, are we going to be above this line or below this line? So I'm going to use 0, 0 once again, just because it's the easiest point. So 2 times 0 minus 3 times 0. I need to see if that is greater than or equal to negative 12. So 2 times 0 is 0. 3 times 0 is 0. Thank you. So 0 minus 0 is 0. So is 0 greater than negative 12? Yes. So I need to shade the point that includes it. So my 0, 0 is below my line. So I will shade below my line. So always shade the point that includes it, if it's correct. So use the same method. Use that same method of standard form. Cover up, find your intercept. See if you can graph the second one. So see if you can do that last graph. All right, so on graphing this, you should have gotten the point at 4 for your x, a point for 2 for your y. We saw it was a solid line. Plugging in 0, 0. Was that a solution or not a solution? It was not a solution. So do we want to shade this side? We want to shade the top because that does not include our 0, 0. So because it was not a solution, we always shade the opposite. Good. All right. So here's a different style question. We want to determine which of these points is a solution to our inequality. So there's a couple ways you might be able to solve this. One way is you could plug each of these points in for your x and your y, and you can see which one works. But you would have, that would be 4 different problems. I'd have to plug negative 6 in for x, multiply it, add 4, see if that's greater than 1. Plug negative 1 in for x, multiply it, add 4, see if that's greater than 6. That would take a lot of time to go through. Another option we can do is we can graph this line, and we can see which of these points fall into our solution. So there's a couple ways you can go about this. It's really whichever one terms up you. So is this standard form or is this slope-intercept form? Slope-intercept form. So anytime the x and the y are on the same side, it's standard form. If the x and the y are on opposite sides, it's slope-intercept. So what's my intercept for my graph? 4. And am I going to use a solid or a dotted line? So because I'm greater than or equal to, I'm going to be a solid line. I have that equals underneath. So my slope is 1/3. So that means every time I go over, or I go up 1 over 3, rise of 1, run of 3, and I determined it was a solid line. So we have our line. Once again, we need to check our solution just to see if it works. So I'm going to plug 0 in for my x and my y. So 1/3 times 0, anything times 0 is 0. So once again, I'm seeing is 0 greater than 4? It's not. So we will go for the top. Now I need to think, which of these coordinates are going to fall in that top green region? So negative 6, 1. Negative 6, 1 is just right there. So that doesn't work. Negative 1, 6. Oh, negative 1, 6 falls within my green region.
There we go.
So that would be my solution.
Excited now, boy.
You could check the other ones if you wanted to as well. 6, negative 1 doesn't land in the region. 1, negative 6 also doesn't land within the region. And so 6 or negative 1, 6 was our only correct answer. So once again, you could have done it a different way. You could have plugged in these values for x and y and seen which ones were correct. That's one way to go about it. What was that? Took too long. Yeah, doing all 4 of the problems. So today we focused on graphing these. In practice, graphing these. One other thing we're still going to talk about. We need to be able to write the equation from the graph. So figure out what is the inequality from the graph. And we have enough time just to do the first one. So, looking at this inequality, I first need to figure out what is the line that passes through this. So it's a dotted line, so I know I'm going to be less than or greater than. I won't be equal to. I need to figure out what is the equation of this line. So I'm going to use slope-intercept form. I think that's a little bit easier typically for finding the equation. So I see my y-intercept is 1. My slope is negative 2, 3. So negative 2/3 x plus 1. This would be my normal line of my equation. I need to figure out what is that inequality that is going to go there, though, because we're normally not an equal sign, we're an inequality. So in order to check that inequality, I'm going to pick a point in my solution. So luckily, 0, 0 is in my solution. So I'm going to plug that into my equation. I'm going to plug that in. So 0 for y and 0 for x. And I'm going to figure out what inequality makes this true. Is it going to be greater than or is it going to be less than? So negative 2/3 times 0, 0. So I need to figure out what inequality should go here. Should be less than or greater than? So 0 is going to be less than 1. I know it's going to be less than and not less than or equal to because of my line. So my answer is y is less than negative 2/3 x plus 1. We're going to practice doing this some more tomorrow, and then we'll practice graphing as well tomorrow.
I know.